Once all 12 nodes had been finished and the device assembled, the results are quite pleasing. It all went together perfectly with no real difficulty in putting it together, and all grub screws screwed up. After the nodes were finished, I polished them first with about 1200 grit wet and dry emery paper, and then polished them quite aggressively with a cloth buff about 6 inches round on my electric drill, and I actually had some special stainless steel polishing buffing compound to use, and that came up very nicely, although you can still see a few marks from the chuck. So here we see a close-up of one of the nodes, which looks quite nice with its grub screws in place. I purchased those separately, and a couple of the nodes that are diagonally opposite each other are extra long for actually attaching the steam engine device, as we'll see in the next slide, where the manifold pipe has been placed across between these two vertical bars, and the boiler tank has been screwed into the bottom of this manifold. I also made a stopcock or tap to control the flow of steam from the boiler, which has come in through the manifold and into the side of the tap. The lever directs that steam up the vertical pipe into the rotor. But there's also a position where you can move it further around and just vent the steam to exhaust in case you have an emergency and want to shut it down. This plug you can see on the end simply directs the steam backwards away from the operator so it doesn't squirt you in the eye. I guess I should have filmed this part too, but this stopcock is simply a hole bored in the outside part of the brass fitting, which is a tapered bored hole at an angle of 5 degrees, and then the plug is made separately with an angle of 5 degrees as well. A horizontal bar was screwed into the end of the tapered plug as a lever to allow us to turn it around, and the other end was turned down to 10 millimeters, and a die used to thread that with a handmade nut actually to fit it, and a spring to hold the plug firmly in its taper. And actually, to make sure it fitted properly, I had to lap it in, which means to put in some grinding compound onto the two parts, put them together, and just turn it round and round and round in the lathe for quite a while, so that one piece grinds into the other so that they exactly match. Otherwise the tapers didn't actually quite match perfectly. In this image you can just see the rotor at the very top. This rotor and the boiler tank were made using the spinning technique that I described in the introduction, and this resulted in two bowls a bit like this, which were joined together to make a tank like this. And if you look closely you can see that the edges are wrapped over, and I had to hold this bowl in a wooden piece that you also saw on the wood turning part of the introduction while I attached the other piece and rolled the edges over. There's the rolled edge. And actually, to make this big hole for the pipe going through the center, I made a thing like a bullet and forced it through the quarter-inch hole that was there first, and that way it makes a kind of a flanged edge on the inside that gives a good area for soldering onto. And that was actually done in the lathe as well to keep it, make sure that the holes are kept straight. Then I ran solder into the rolled over edge to seal it properly, and then in this photo you can actually see a grease nipple I've placed here, and I've taken the little ball and spring out of it, so now it acts like a jet. The grease nipple is particularly convenient because the end of it can be unscrewed, and I can make different sized jets and put it on it and try different ones and check performance. And actually I discovered that the jets used in 3D printers also screw in with a 6mm thread, so they can be used as well as jets. In keeping with family tradition, I decided to incorporate a coin, so that's actually placed in the filler cap here, which actually had a little recess, and I filed the coin down to be just the right size to press into that space. This will give people in the future a rough idea of when it was made, although the exact date is not on it. But you may recall that my grandfather also put a penny over the spout of the kettle when he built his Hero steam engine. And this is the stage we're at now, where I've completed the lower level with the boiler, the middle level with all the controls, and the upper level has not been done yet. The upper level consists of the spinner or rotor that spins around with the steam ejection, and I need to make bearings for it and mount it on the top of the steam uprisers. In this photo you can just see the 6-inch buff on the left hand side that I used for polishing everything. Here you can see why I made this cage to protect the boiler without actually attaching anything to the boiler apart from the actual steam outlet and filler cap, of course. And I think that serves the purpose quite well, both supporting the boiler and protecting it. This was made in the same way as the rotor, two bowls that were joined together with a rolled over edge which was soldered, and then it was pressure tested, and I filled it with compressed air up to a pressure of 15 pounds per square inch, and that is actually the cutoff of the pressure relief valve. So it opened and the pressure gauge went straight up to 15 psi, and right on the dot of 15 the pressure valve opened, and there was no sign of any difficulty with the tank, no leakage or bulging or anything. Atmospheric pressure is about 14 pounds per square inch, so that's what I wanted to achieve, was 1 atmosphere, and at that we should have the steam reach the speed of sound in the jets and reach maximum possible velocity, and so that was the goal. When you're doing this kind of testing, it's a good idea to fill the tank with water first and then just add a little bit of compressed air to give the pressure you want. That way, if it ruptures and bursts, there's not a lot of expansion takes place because water's non-compressible, and if it was to burst, it would just sort of pop open without causing a major explosion, whereas air inside under high pressure could blow it wide apart and throw bits of metal at you. So that is the end of this particular series, although I may add more later when I complete the whole process and complete the project. So good luck with your projects, and I hope you enjoyed the series and got some useful information out of it.